I'm Anil Kumar. Welcome to my series on solving previous test questions. This one is based on calculus from IB Higher Level Paper 2. Consider the curve C defined by the equation y square minus 2xy equals to 5 minus e to the power of x. The point A lies on C and has coordinates 0, a, where a is greater than 0. It has three parts. Part A, find the value of A, B. Show that dy dx is equal to 2y minus e to the power of x divided by 2 times y minus x. And part C is, find the equation of normal to C at point A. You can always pause the video, answer the question, and then look into my suggestions. So part A is relatively simple. We just need to find the value of A where the x value is 0 in the given equation, which is y squared minus 2xy equals to 5 minus e to the power of x. So if I substitute x equals to 0, then what do we get? We get y squared, that is 0, right? And we get, let me write, minus 0 equals to 5 minus e to the power of 0. Anything to the power of 0 is 1, so we get y squared equals to 5 minus 1, which is 4. And so we get y as equal to plus minus square root of 4, which is equal to plus and minus 2. Since we are given that a is greater than 0, we have to take the positive value, so y is equal to 2. And that means the value of a is 2, right? So that gives a as equal to 2. So we know the value of a now. Part B is show that dy dx is 2y minus e to the power of x. So let's find the derivative of the given function. So I'll use this part of the page now. Okay, so again we'll begin with the basic equation given to us. Y equals to 2xy equals to 5 minus e to the power of x. Taking derivatives with respect to x, we get 2y dy dx minus, product rule will be applied here. First differentiating with respect to x, let me put brackets here, we get 2y, and then differentiating with respect to x for y. So 2y plus, we get 2x dy dx. Okay, and here we get 5 minus, so derivative of 5 is 0, right? And minus e to the power of x is minus e to the power of x. So that's what we get as our derivative. We can isolate dy dx. So what we have here is 2y dy dx minus 2y minus 2x dy dx equals to minus e to the power of x. Taking dy dx common, we get 2y minus 2x, right? Or we'll take 2 common later. 2y minus 2x. 2y on the other side minus e to the power of x. Correct? So clearly dy dx is equal to 2y minus e to the power of x. Let's take 2 outside, write it just as required, y minus x. Is that clear? So we do get the same derivative, and that's it, that's required. And C part is, find the equation of normal to the curve at point A. Now when I say at point A, means the point A now for us is 0 and the value of A is 2, right? So 0, 2. So now for normal, Let's also see what dy dx is, since there's very less space here. Let me write here dy dx when at point A will be when x equals to 0. And y, let me write y equals to 2. So what is that derivative? We should find this, right? So this is substituting x equals to 0 and y equals to 2. We get, okay, let's do it here. So that's what we'll do. So normal is negative of 1 over slope m, right? So we'll find dy dx here. So if I substitute x equals to 0, then this becomes 1 and y equals to 2. So what we get here is, let me write here. First dy dx is equal to, substituting y equals to 2, we get 2 times 2 minus e to the power of 0 is 1 over 2 times 2 minus 0, correct? X is 0. So that means 4 minus 1 is 3 over 4. So the normal will be what? So this is slope m, right? So normal slope, let me write this as slope of normal will be negative reciprocal, negative 4 over 3, clear? And the point we're talking about is 0, 2. So the equation of the normal will be y minus y1, which is 2, equals to minus 4 over 3 x minus 0. So you can write it in standard form. We get 3y minus 6 equals 2 minus 4x, or we could write this as 4x plus 3y minus 6 equals to 0. Right. So that becomes your equation for the normal at point A on this curve. Is that clear? So this is how we can actually solve this particular question. So I hope all the steps are absolutely clear. Sharing with you questions from different test papers is giving you a good idea about the type of questions you should be working on. And I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.